So this is where you made the clouds that will cool the Earth?
What we want to do is to create clouds that has a lot of droplets.
It's kind of like fog.
Yeah, it is fog.
I mean, it actually is fog, yeah.
I'm Athena Brensberger. Welcome to Suppressed Science.
Geoengineering is the name given to large-scale scientific endeavors aimed at controlling or modifying the planet itself. It is the latest and most high-tech step in a long history that includes things like weather control and terraforming. And it has been a misunderstood field that often yields more conspiracy theories than results. Today, techniques like carbon capture and solar geoengineering are considered by some to be the most viable means to fight the existential threat posed by climate change. Rising tides, heat waves, droughts, hurricanes, and melting ice caps are all compounding and accelerating signs of our planet Earth becoming a harsh and uninhabitable world. As scientists work to find ways to turn back the tides of climate change, some believe that our only hope stems from a very polarizing new field called geoengineering.
As usual, it gets complicated and it gets controversial, but the science is real, and one day it might save us.
But the problem is there could also be severe consequences, and depending on who you ask, it is often hard to get a clear definition of what geoengineering even is.
It's a pleasure to be with you. So I'm David Victor, and I'm a professor here at UC San Diego, and I teach in atmospheric science and climate science, and then I'm in the mechanical and aerospace engineering department where we work on deep decarbonization and how the electric grid will respond to the need to cut emissions.
Well, can you actually start off with maybe giving us a definition of geoengineering, as there seems to be sometimes difficulty in trying to define it?
Well, so it's one of those terms where I think people have allowed the definition to be sloppy. And in that world, a whole set of different activities have really become lumped. And there's two in particular that really matter. One is what's often called carbon dioxide removal, the idea that you would engineer, whether it's by machines or you'd engineer plants, so that you would suck extra carbon dioxide that's already built up in the atmosphere. 50 parts per million, 100 parts per million, huge amounts of carbon dioxide eventually, suck it out of the atmosphere and put it safely into rocks or underground or some combination of the two, or in the soils, something like that. And then there's another flavor, a very different flavor of geoengineering called solar radiation management. This is the idea that you could directly manipulate the reflectivity of the planet. And frankly, when I take a look at it, that we're considering options like that is a sign of how far real climate change has gone, that we might need to basically play zookeeper for the entire planet.
What were some of the reasons for people that have been opposing doing geoengineering research?
Well, I think people are opposed to it partly because it gives them the heebie-jeebies, right? I mean, or whatever the technical term is for that. I mean,
I think that's a technical term.
People are very uneasy, as they should be, that things with climate change have gotten so out of control that we are considering playing God with the planet.
So at this point, the main concerns are the unknowns. We have no idea what's going to happen if we try this at scale, because even conducting studies on geoengineering, we'll have to actually do it, because the way the climate works, it's all about averages, right? There are a lot of fluctuations. To know whether we're actually having an impact on the climate, you have to do it at a large enough scale and measure it over a long enough time period that we would actually be changing the climate.
We don't really know what the side effects would be. One of the things we learned when we do gigantic global experiments is that the things we predicted would happen don't always happen, and other things happen that we didn't expect to happen at all. We just don't know. Could it affect the monsoon? Could it create winners and losers in different parts of the world? That's almost certain to happen, but we don't know where they are.
I think that people that want to continue to allow the fossil fuel industry to operate as it's been operating have more of an interest in geoengineering, because it'll supposedly give us more time. One of the main criticisms of geoengineering is that it doesn't solve the main issue that is causing climate change, and that's the greenhouse gases that we're emitting into the atmosphere. It's a Band-Aid instead of a cure.
I wanted to continue my research on geoengineering. It feels like there are a lot of people that know about this science, even though it's new to me. So I went to UCLA to meet up with Professor Ted Parson.
So I'm a professor of environmental law here at the UCLA Law School, and I'm also the faculty director of the Emmett Institute on Climate Change and the Environment, which does policy and legal analysis related to mostly climate change. I've been active and working in environmental policy and law since the start of my career, and I've been interested in geoengineering for about 10 years now as things have come to look worse and worse on climate change.
So after 10 years of exploring geoengineering, I wanted to know Professor Parsons' opinions on carbon capture and solar radiation management. Is either of them a feasible solution to climate change?
Carbon dioxide removal and solar geoengineering. I mean, it sounds a little glib, but the way I'd summarize the current sort of attitudes toward both of them is that carbon dioxide removal is too popular or is received with too much uncritical enthusiasm. Not because it's a bad thing, but because people are counting on it to do more than might be possible or acceptable. Solar geoengineering, the other one, that's modifying the energy balance between the Earth and space, that, in my opinion, is hated and feared more than it should be.
Let's break down the process of stratospheric solar radiation management. Step 1. Get all the way up to the stratosphere. Step 2. Release a fine mist of trillions of tiny reflective particles. Step 3. Let the high winds and homogeneity of the stratosphere do its thing. If the particles are tiny and plentiful enough, they will be dispersed across the entire globe and stay up there for over a year, bouncing back just enough sunlight to cause a minor but vital cooling effect to counteract the impact of climate change.
The reason we know it works is that there are natural things that do it. Occasionally there are huge explosive volcanic eruptions that shoot huge plumes of sulfur into the stratosphere. The most recent of those was in 1991 in the Philippines. It was called Mount Pinatubo. And that injected 20 million tons of sulfur into the stratosphere. And the effect of that was to cool the Earth by 1 degree Celsius for about a year or two. Did you notice?
No.
No. So what's being discussed for geoengineering is replicating more gradually and in a more controlled way something that nature already does occasionally and explosively.
So why would you say that people are afraid of this, afraid of having something like this in our immediate future?
The most serious reason that people are afraid of it is that they're afraid it will be mistaken as a magic bullet or a single technical fix that makes the problem go away. And thus, doing this or even talking about it or researching it, they're afraid would weaken the already horribly weak resolve for the intensity and seriousness of emission cuts that are essential. Something I have to say, and it's really important, and everybody who works in this field has to say it at the start of every public talk, is the first priority response to global climate change is cutting emissions to zero or near zero. Nothing displaces that. Nothing replaces that.
I am an atmospheric chemist. I've been teaching at UCLA for about 26 years now. My overarching view is that all of the methods that have been proposed so far to increase reflectivity have significant drawbacks and significant uncertainties and potential unintended consequences. For example, if we introduce aerosols into the stratosphere to increase reactivity, there are lots of different materials that we could introduce, and they have different properties. Eventually, they will come down to the Earth, and they will do something. While they're up there, they will almost certainly damage the ozone layer. It has pretty high potential of changing precipitation patterns, which obviously is something that is of great concern. That said, it is something that we should probably explore so that we can understand it better.
Remember, the debate over this is not we should do it or we should not do it. The debate is, should we do research and even think about the possibility? The reason, in my view, it's essential to do the research and think about the possibility is how bad things might be on climate change and how limited the ability to stop or reverse those might be through the preferred top-line responses, cutting emissions and adaptation.
What would be some of the relevant legal and policy regulations around geoengineering in general?
So for a lot of geoengineering, especially the ones that have to do with atmospheric injections, so like solar radiation management, those impacts will extend beyond any borders of any country. So anything we do to the atmosphere is going to affect the entire planet. And that hasn't stopped us from burning fossil fuels, so, but we need to be more careful this time around. So that's one of the policy problems. Who should be responsible for approving this thing that's going to impact the whole world? Who should have to pay for it? Where should the studies be done? So far, that's another barrier to a lot of studies on geoengineering in the atmosphere, is no one wants to be in the location where we try it for the first time.
Yeah.
I mean, one of the remarkable things about it is how cheap it is. Early estimates, early speculative estimates, suggest that the cost of a program to cool the Earth a degree or two is on order a few $1 billion a year.
At this point, it'll probably be some tech billionaire that does it.
Yeah, why do you say that?
Just seems to be the way things are going. Yeah, I think the new space race is a good example of that. I think if we could do that for climate, it would be great, but it makes me a little bit nervous that maybe geoengineering is the route that they'll go.
I'm increasingly skeptical that it's going to be the Western countries that actually deploy geoengineering. It's hard enough just to build a research program and get public consent to go do field experiments where you put a kilogram or two of material in the upper atmosphere. You're going to see it from a country that might do it in a clandestine way, where there's going to be interesting political questions of, would we know if some other country started a program like this? Would we be able to detect it? It's a little bit like the first launch of nuclear weapons. Suppose a government feels like it's under pressure to do something about the climate change problem, and it can't by itself do very much about it because emissions come from lots of different countries. Say you're Bangladesh, you've got a GDP of $120 billion a year, and you are being hammered by climate change, and you look at your own emissions and you say, well, I as Bangladesh can't do anything about this problem, but maybe I could go off and develop my own geoengineering program and have specialized aircraft and so on. And that might seem kind of crazy for Bangladesh to do that.
It's political, but it's also scientific. It has to have broad enough global participation that it's legitimate, that there can be confidence that the decisions it makes are being made in the interests of human welfare worldwide, and not to try to defend or protect any nation or region or faction. And that's long work. In fact, that's longer, harder work than the scientific research and technology development. So it needs to start now.
So with the long and complicated road ahead for geoengineering, I needed to find out if there are any people actually pursuing it yet. And my search led me to Palo Alto.
I'm Kelly Wanzer. I am the founder and executive director of an organization called Silver Lining, which is a nonprofit that's focused on the near-term risks of climate. So what do we need to think about in the next 30 or 40 years in terms of keeping the climate system safe? Many years ago, I came across kind of a scientific community that was looking at this question of, if you needed to reduce warming quickly, what are the kinds of options that you have? They did a couple of these, big sort of grand science meetings where they went through all the different possibilities, like putting tiny bubbles on the ocean, or mirrors in space, or plastic sheets on the Arctic, or painting roofs white, or having brighter crops. And from assessing those things, they landed on, tweaking the atmosphere in this way is really the most promising way to cool the planet quickly if you needed to. And so my organization, Silver Lining, we're very interested that we take a really strong, rigorous science approach to understanding whether these things might be possible and if they might be tools to help keep us safe while we do all the things that we absolutely need to do to make the planet sustainable. And we're sitting here at Palo Alto Research Center, which is famous from the 1980s for lots of inventions like the computer mouse and parts of the microchips and Windows screens and things like that. And what we're here working with them on now is, could you generate really clean, really optimized particles to help brighten the atmosphere?
My name is Sean Garner. My background is in physics. I have a PhD in physics. I oversee the engineering part of the Marine Cloud Brightening project. Marine Cloud Brightening is the idea that it might be possible to spray salt water over the oceans, make the clouds that already exist over the oceans a little bit brighter, reflect more sunlight back to space, and cool the Earth in that way.
Unlike the stratospheric version, marine layer solar radiation management takes place just a few thousand feet above the surface of Earth. The proposed technique is to use the ocean itself as the source of particles, in this case, tiny salt crystals, which are injected into the thin clouds above the sea to produce the reflective cooling effect. Because it happens much lower, the effect only impacts the local area and only lasts for about 1 week. This means that it isn't as widespread or long-lasting as the stratospheric version, which, depending on which side of the debate you are on, could be a good thing or a bad thing.
One of the ways to think about solar climate interventions is at the different layers of the atmosphere that they operate. So marine cloud brightening is operating at the lowest layer of the atmosphere, and it's localized and temporary, which means you have a lot of control. It's really easy to turn it on and off. And it's really easy to do experiments that are very small and figure out whether you can brighten an area of clouds.
We're working here on the engineering side. We're trying to figure out how would you do this. And more importantly, in the near term, we'd like to enable the folks at University of Washington to do meaningful experiments. So what that means might be to take one boat on the ocean, spray some saltwater particles behind that boat, and change the reflectivity of the clouds enough to measure. Right, and that would give some badly needed experimental data to show that this technique might be possible.
After speaking with Sean and Kelly, they offered to give me a behind-the-scenes look into the lab where they are conducting experiments to actually begin testing the marine cloud brightening methods.
So this is the setup that we are working on to be able to produce these tiny, tiny droplets that will carry the crystal salts that will work as the cloud condensation nuclei. Basically, you see like a huge plume, like the whitish plume here. The droplets are actually forming that plume. The water content evaporates. What we are left with is those salt particles that we are interested in. This is the nozzle. The pressure chamber is right here. It's where the two flows, they will meet each other. The air is coming through this side, and brine is coming through this side here.
So you've been really emphasizing how these particles are really small. Why do they have to be so small?
They have to be small because what we want to do is to create clouds that has a lot of droplets. Because this type of clouds will help us to bounce the radiation coming from the sun back to space. So the more droplets we have, the better. If they are too big, they will actually create large droplets. Large droplets will fall as rain.
I see.
That's why it needs to be in this specific range.
So I probably shouldn't be facing the nozzle when this goes off.
You guys don't want to be here.
It's kind of like fog.
Yeah, it is fog.
I mean, it actually is fog, yeah. Would we be able to take this technology and say, bring it out on a boat, out in the water, and then do the experiment out there?
Yeah, well, that's the hope, but we don't know exactly if that's going to work. So here we have a controlled condition. We are measuring the temperature. We choose what's the relative humidity that we want to work at. When we go to a boat, things will be different, and we know that. But the hope is it's not going to be different to the point that it's not going to work anymore. But hopefully, it's going to give us the results we want.
You know, I think an important misconception that's out there is that, anybody who's doing research on this is dying to go out there and use the technique, right? And I think that's absolutely not true. I mean, I think these are techniques that we need to be very careful about whether we use, and that has to be decided as a global society, really. It's our job to make the data available so that that decision can be made in an informed manner.
The main objection to research in this area has come from within the climate community. Climate activists, even climate scientists, who are really worried that this idea could be taken advantage of by people who want to continue polluting. You know, we welcome people who think about this in a really practical way, because it's not been an easy thing to just sort of desensationalize and get people thinking about, you know, what the realities are and what's really at stake. Our vision from the beginning has been that within a decade, that we can ensure safety, that we can tell young people, people in the global south, people in the United States, within a decade, that we have a plan. We are not going to let the system get out of control. We're going to keep people safe. This area has had no funding from anywhere until a few years ago, this area of solar climate intervention. And it's been very taboo. And it's still very difficult in terms of foundations and climate advocacy, and even some of the big environmental groups whose scientists might say, this is something we should be talking about and thinking about, but their organizations can't. And so even big environmental organizations, most of them, they don't have a statement on this, they've never had a meeting on it.
People on both sides, you know, people who are very for and very against, you know, I think are all deluding themselves about how much we actually know about it today. I think the science is really missing. We don't understand the possible benefits or the possible risks. So I think the right thing to do is to do the science carefully, do the science in an open and transparent way, and that will enable decision makers to actually have the data that they need to make these decisions.
Hearing all this, it made me wonder, if solar geoengineering is reserved for the worst case scenario, what is the best case scenario?
So the best possible world, aggressive cuts in emissions, aggressive development of carbon dioxide removal so that if we go too far, we have a possibility of coming back. Research, development, and if necessary, use of solar geoengineering in a limited, temporary way to shave the peak of that horrible 30 or 40 or 50-year period of extreme climate impacts that we would be facing and aren't controllable in any other way.
I think people are worried about the impact that we're having on the planet because they think that humans can only negatively impact the planet. But I don't think that's true. I think we can find ways to live in concert with the world around us and change it for the better.
It is truly amazing that something like weather control, which was once the territory of scam artists and snake oil salesmen, could actually be at the crux of the debate about the long-term viability of human survival on Earth. We've gone from not knowing if the methods work at all to worrying they might work too well. Whether or not you agree with applying these new methods today, the fact is we're all here together on Spaceship Earth. And one day, she might just need a tune-up.